We've been given some interesting information here about the functions f, g, and h. For f, they tell us for given values of x what f of x is equal to and what f prime of x is equal to. Then they define g of x for us in terms of this kind of absolute value expression. And then they define h of x for us in terms of both f of x and g of x. And what we're curious about is what is the derivative? What is the derivative with respect to x of h of x at x is equal to 9. And so I encourage you to pause this video and think about it on your own before I work through it. So let's think about it a little bit. So another way, just to get familiar with the notation of writing this, the derivative of h of x with respect to x at x equals 9, this is equivalent to h, let me do it in that blue color. It is equivalent to h prime, and the prime signifies that we're taking the derivative, h prime of x when x equals 9. So h prime of 9 is what this really is. So actually, let me do this in a different color. So this is h prime of 9. So let's think about what that is. Well, let's take the derivative of both sides of this expression to figure out what the derivative with respect to x of h is. So we get a derivative, let me do that same white color. A derivative with respect to x of h of x is going to be equal to the derivative with respect to x of all of this business. So I could actually I'll just rewrite it. 3 times f of x plus 2 times g of x plus 2 times g of x. Now, this right over here, the derivative of the sum of two terms, that's going to be the same thing as the sum of the derivatives of each of the terms. So this is going to be the same thing as the derivative with respect to x of 3 times, let me write that a little bit neater, 3 times f of x plus the derivative with respect to x of 2 times g of x. 2 times g of x. Now, the derivative of a number, or I guess you could say a scaling factor times a function, the derivative of a scalar times a function is the same thing as a scalar times the derivative of the function. What does that mean? Well, that just means that this first term right over here, that's going to be equivalent to 3 times the derivative with respect to x of our f of x, plus this part over here is the same thing as 2, we can make sure I don't run out of space here, plus 2 times the derivative with respect to x. The derivative with respect to x of g of x. So the derivative of h with respect to x is equal to 3 times the derivative of f with respect to x plus 2 times the derivative of g with respect to x. And if we wanted to write it in this kind of prime notation here, we could rewrite it as h prime of x is equal to 3 times f prime of x. So this part right over here, that is the same thing as f prime of x. So it's 3 times f prime of x plus 2 times g prime of x, plus 2 times g prime of x. And once you kind of are more fluent with this property, the derivative of the sum of two things is the sum of the derivatives, and the derivative of a scalar times something is the same thing as a scalar times the derivative of that something, you really could have gone straight from here to here pretty quickly. Now, why is this interesting? Well, now we can evaluate this function when x is equal to 9. So h prime of 9 is the same thing as 3 times f prime of 9 plus 2 times g prime of 9. Now, what is f prime of 9? The derivative of our function f when x is equal to 9. Well, they tell us when x is equal to 9, f of 9 is 1, but more importantly, f prime of 9 is 3. So this part right over here evaluates, that part's 3. But what's g prime of 9? So let's look at this function a little bit more closely. So there's a couple of ways we could think about it. Let's try to graph it. Now I think that could be interesting, just to visualize what's going on here. So let's say that's our y-axis, And this right over here is our x-axis. Now, when does an absolute value function like this, when is this going to hit a minimum point? Well, the absolute value of something is always going to be non-negative. So it hits a minimum point when this thing is equal to 0. Well, when is this thing equal to 0? When x equals 1, this thing is equal to 0. So we hit a minimum point when x is equal to 1. And when x equals 1, this term is 0, absolute value of 0, 0. G of 1 is 1. So we have this point right over there. Now, what happens after that? What happens for x greater? What happens for x greater than 1? Actually, let me write this down. So g of x is equal to, and in general, whenever you have an absolute value, a relatively simple absolute value function like this, you could think of it, you could break it up into two functions, or you could think about this function over different intervals when the absolute value is non-negative and when the absolute value is negative. So when the absolute value is non-negative, that's when x is greater than or equal to 0. X is greater than or equal to 0. And when the absolute value is non-negative, if you're taking the absolute value of a non-negative number, then it's just going to be itself. The absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 100 is 100. So then you could ignore the absolute value for x is greater than or equal to, not greater than or equal to 0, for x is greater than or equal to, x is greater than or equal to 1. X is greater than or equal to 1. This thing right over here is non-negative. And so it'll just evaluate to x minus 1. So this is going to be x minus 1 plus 1, which is the same thing as just x. Minus 1 plus 1, they just cancel out. Now, when this term right over here is negative, and that's going to happen for this is going to happen for x is less than 1, well, then the absolute value is going to be the opposite of it. You give me the absolute value of a negative number, it's going to be the opposite. Absolute value of negative 8 is positive 8. So it's going to be the negative of x minus 1 is 1 minus x plus 1. Or we could say 2 minus x. 2 minus x. Now, so for x is greater than or equal to 1, we would look at this expression. Now, what's the slope of that? Well, the slope of that is 1. So we're going to have a curve that looks like, or a line, I guess we could say, that looks like this. That looks like this for all x's greater than or equal to 1. So the important thing, remember, we're going to think about the slope of the tangent line when we think about the derivative of g. So slope is equal to 1. And for x less than 1, well, our slope now, if we look right over here, our slope is negative. Our slope is negative 1. So it's going to look like this. It's going to look like that. But for the point in question, if we're thinking about g prime of 9, so 9 is someplace out here. So what is g prime of 9? So g prime of 9, let me make it clear. This graph right over here, this is the graph of g of x. Or we could say y, this is the graph y equals g of x. Y is equal to g of x. So what is g prime of 9? Well, that's the slope when x is equal to 9. Well, the slope is going to be equal to 1. So g prime of 9 is 1. So what does this evaluate to? This is going to be 3 times 3. So this part right over here is 9 plus 2 times 1 plus 2, which is equal to 11. So the slope of the tangent line of h when x is equal to 9 is 11.